Number 40. Suppose the output of the machinery in a factory that can be considered as a continuous income stream with an annual rate of flow at time t given by f of t equals 450 e and negative 0.09 t. And this is in thousands of dollars per year. So what they're doing is approximating the actual output of the machinery by this continuous function. And the reason they're doing that is it makes certain other calculations easier to do, like capital value, which is what we're being asked in this. So if the annual interest rate is 6% compounded continuously, what is the capital value of the machinery? So we're trying to find capital value. We'll call capital value is the interval from 0 to infinity of the income stream and then compared to the current interest rate. All right, so plug in the values that we know. So we know what the income stream is. And that's 450 times e to the negative 0.09 t. And then we have the interest rate of 6%. So we want to evaluate that. So these are multiplied. That's going to come into play in a second. But first, deal with this. So that's as the upper bound moves. So we'll now, so this is the integral we need to evaluate. So this, as it's written, is hard to do, but if we realize that what we have is two exponentials that are multiplied, and they have different values in the exponent, but we can, the multiplication turns into addition of those exponents. So 6% minus 6% and minus 9%. And the exponent. Suddenly, that is now easier to work with. Got this limit here. Okay, so 0 to b, 450. This is e to the negative 0.15 dt. The limit. Okay. So using a u sub to solve for this, so it's a relatively straightforward u sub. U sub is u is negative 0.15 t. Just take the derivative. So that's negative 0.15 and then dt. So we have dt, we need this right coefficient in front of it, so we have our u there. So let's write this so there's a little bit more space. So we need to put this term in. It's times. And so when we do that, we have to also divide by it. All right, so those will cancel to go back. So it stays equivalent. Okay. So this is coefficient, which is constant. It can just get pulled out. And then we're left with, those make the du. That's the u. And so our substitution is good. Because this limit is in terms of x, it's better to make the u sub and then switch back to the t variable. So that coefficient there, we have u of 0, u of b, and then this is e to the u du, and we still have this limit here. Okay, but the u sub worked, so that's e to the u evaluated from u of 0 to u of b. You have this coefficient in front, which I'm going to evaluate shortly. Limit as b goes to infinity. Okay. So this coefficient here is 3 times 15 times 10, or so this will cancel, giving that in the bottom. All right, so the 15s cancel, so you have 30, and then shift the decimal over twice. So 30, and then 2 decimal shifts, 3,000, and it's negative, so negative 3,000. E, we're going to put back into our t variable now. And so now we're at b, those bounds, and then as b goes to infinity. Okay, so plug in, minus 3,000, e to the negative 0.15b, minus 3,000, e to the negative 0.15 times 0. Okay, and we still have the limit here, which we're about to evaluate. Okay, so that is 0, so we have e to the 0. E to the 0 is 1, so that's 1, and then minus minus is plus, so plus 3,000 times 1. This term, we have b going to positive infinity, but we have a minus sign here, so we're going to have negative big number in the exponent, so we have e to this negative big number. That is going to head to 0. So 0 times minus 3,000. So that is 0, and then plus 3,000. So the result is 3,000. Now it's asking what the capital value is, so you have to adjust for all the units here. So the capital value is going to be 3,000, and then this was in thousands of dollars, so you multiply it by 1,000, which adds 3 zeros to the end there. So the capital value is of this machinery is $3 million.